Now we are going to talk about the sequence type. Generally, the basic concept is we have the multiple element or the multiple object in the sequence type of the data, and the index start from 0, right? So the first item has the index 0, second item has index 1, and so on. And Python has built-in mutable and immutable sequence type. So the string tuples, these two data types are immutable, right? That means you cannot modify the content. That means once the type data is created, it's been created, you cannot modify it later on. So consider these example over here. Here we have created a tuple with the 3 element, and now we can access the element. So here we are trying to access the first element, and then the first element index is 0. So we have to use with this index value. Now here I'm trying to set a new value at the 0 index. So which is I'm trying to modify the content. If I run this, we'll get error because this tuple does not support item assignment, or you cannot modify the content, right? But if the sequence contains the mutable object itself, although we cannot modify the sequence of element, like you cannot modify the tuple, but consider that inside the tuple you have a sequence, another sequence data, and that is mutable. Consider this example over here. Here we have this tuple. In this tuple, the first element is list, and the list is mutable. So you can mutate and you can change this object, though you cannot change this entire tuple, right? So here, what we're trying to do is we are trying to change this first element of the list, and we can do that. And now when we see this here, we can see that this internal this list has been modified, but the tuple has not, right? Now we are going to talk about iterable concepts. So what are the iterable? It is something that you can iterate over a loop, right? So again, a sequence data is also the iterable, that means you can iterate each element. So consider this example over here. Here we have this T as a tuple and then S as a set. Now we can, because both tuple and the set both are iterable, you can take a loop of that. Here we can see that, right? Now Now we'll talk about the in and not in operator. In operator will check that whether this, like over this example, here we have this A in this list. Basically, we are checking that whether this A is present in this list or not. If it is, we'll get true, otherwise we'll get false, right? Here, again, you can also check this in operator with the 100. So here we are saying that whether this 100 is present in range 200 or not. Basically, it is. So we'll get true over here. Now, in the sequence data, it also supports min max and the length function. Directly we have accessible. So we can, like here we're trying to check the length of Python, which is a string. It is also sequence data. Again, we are trying to check the length of the list. This is also sequence data. Again, the length of the set and the length of dictionary we are seeing, right? So we can get the output. We can also get the mean and the max value, right? If the value inside that sequence data is comparable, right? That means you can compare whether this one value is less than or not. Then only you can check min and the max. Like over here we have this list. In this list we have this 100, 300 and 200, which is comparable. We can check min and max. We can access the direct min function and max function, right? Now again, string, here with the string we are also comparing min and max, and again we can compare that because this string, each character has the some basic bits and byte value, right? So you can compare based on that. Here we have this set, you can also compare min and max to the set. Now consider these value, right? Now here we have this list of complex number, but this complex number cannot support ordering. So sorry, not ordering. So complex number cannot support this comparison, and so you cannot find the mean and the max value over here, right? Now here you can also compare, like let's say that if you have this different object like the decimal object, you can also compare that. For example, consider this over here. We have created a decimal object. this is a tuple we are creating. We can take the mean and the max of that, right? Now here we have this one is string, but again this one is string but other values are not, right? So these are the integer values, so you cannot compare this string and integer value, you cannot compare that, so we cannot do min and max value over here. We can take min and max value to the range function as well, right? Now we'll talk about the concatenations. So we can concatenate the sequence data using plus operator like this. We have the to list and now we are concatenating the to list over here with the plus operator. We can also concatenate the to tuple. Now if we have the list and then the tuple, right, this cannot be possible. So let's say that here one is the list, so one is the tuple, this first element is tuple and the second element is list. You cannot concatenate this two different type of sequence data over here. This will not work, right? It can only work if both of the sequence data are of the same type. Again, here we have this one is string, other one is a list. This will also not work. So basically what you have to do is you have to convert one of the element to the common type. Like over here we have this tuple and this was the list. So first we are converting this list to a tuple and then we are trying to add it. This will work. Same thing we are doing over here. We are converting string to tuples and then we are adding it. Same as here, first we have converted this string to tuple, then again we have the, so again this second element is still the tuple we have and then we are joining with the string. We can also do that, right? Now we'll talk about the repetitions. So most sequence type also support the repetitions, which is essentially a concatenation of the same sequence data of that many number of type. Let's say that here we have saying, here we have this ABC into 5. This means that we are concatenating ABC string 5 times. So this is not like multiplying 5 values. So this is like concatenating this the same string with the 5 times and we'll get the similar result over here. The same thing we are doing over here. So we are concatenating this list 5 times, right? Now finding things in sequence, we can also use index object to find the object. Like over here we have the string. Let's say that we are saying that s dot index n. So this will give you the index of this n object. The same thing we are doing over here. Again, if that particular index is not available, so it will give you the error, right? So here we are trying to find that whether this n is available beyond 13 or not, right? So this will crash, right? Now, okay, so here we're getting the value error not found, right? Now we'll learn about the slicing. So here we have the two string, one is string, other one is a list. Now we can slice the string, right? For the slicing we have to give the index. So here like in the S we are saying that 0 colon 3. This means that we want to include 0 but 3 is being excluded. So we'll get the value 0 1 2. So we'll get 0 P Y T 0 1 2 will get this value, right? And same thing we are doing over here. We are saying 4 to 6. So we'll get the value of 4 and 6, right? And same thing we can do with the list, right? Now we can also extend the range. Like over here we are saying that S4 colon 1000. This means that we want to extract the element from 4 to all the way to 1000, even though the values are not present in 1000. So we'll get 4 till whatever the value we have available. So here we have this fourth object is O and the fifth object is N. So we are getting ON over here, right? Now if you omit the starting value, let's say that here we are saying that S0 to 3, this is similar to S empty. So we are not passing anything over here, colon 3. So we are omitting these three values, this 0 value. So or if you omit, if you do not write anything at the starting value, so that will be considered as 0. So both will give you the same output, right? Now here we are trying to access from third to 1000 and then here we are saying that from third to colon this. So we are not passing any value. This means that we want to extract all the sequence from third to whatever the sequence we have available, right? So it will extract from third to all the way to end, right? So this will give you the similar result. And again this means that So in this scenario, we are not passing the starting and the end value. So if you do not pass the starting and the end value, so this will give you the entire string, right? Now, instead of passing, so again, this was the start and the end. And instead of passing start and the end, you can also pass the step value, like over here. In this, so here, this will give you the entire string. In this string, we are passing 0 to 5. So 0 is the starting index and 5 is the end index, right? And then here, we are also passing start, end, and then we are passing step value. So here what we are getting is, so when we provide the step value, that value will be skipped. So we are saying that 0 to 5, 0 to 5 means this. And then in this object, we are saying 0 to 5 colon 2. This means that we are saying that we want to extract the 0th index, then we'll skip the next index, then again we'll get the the third index, right? So we are saying, so here we have this p, which is the 0th index, and then we have skipped y, then we are getting t, then again we have skipped h, and then we are getting o. So step value will be, so step value, if you are passing the step value, it will be skipped by 1. So by default the step value is always 1, right? Here we have the 2, so this one value will skip after every output. Then if you'll, like, let's say that if you'll pass 3, so the 2 value will be skipped, and this is how the output will be, right? You can also pass this colon 2. This means that we want to extract every value, right? And then here colon means we want to extract all the value, and then the 2 is passing, we are, so again here we are passing 2, which is the step value. So again p, then again we'll skip, then t, then again we'll skip, then again o, and then again we'll skip. So we are getting pto. You can also do the reverse indexing or negative indexing. So here first we are passing that we want to extract the value from, again let's see the result. Here for s we are getting Python. Then we have this s minus 3 colon minus 1. This means that, so again the index, the negative index start from here. So n have the minus 1, o have the minus 2, h has the minus 3, and so on. So it will start from h and end till minus 1. So ho, because this minus 1 will not affect, so will not consider, so we'll get ho. And then colon minus 1 will reverse this entire index, right? Now here in the range also, let's say that if you are using the range like range 11, this means that the 11 value will be excluded, so we'll get all the value from 0 to 10, right? We can see the value here, we are printing the range, but that will not give you the exact value we have, but if you convert those output to a list, then we'll see all the object inside that. Here we can see that, right? Again we can also slice this range, like over here this will work, right? So we are getting 0 to 4. Now we'll talk about the hashing. So immutable sequence generally support the hash method. We'll see later on how the hashing work. But again, here we have this tuple, because tuple is immutable, so you can get the hash value of the tuple. Here we are having the hash value. Same as we are getting the hash value of the string, because string is also immutable. But the range is also immutable, right? So we are getting the hashing value of that, right? But for the mutable sequence, the hash value does not support. Like we have this list, you can modify the list, because you can modify, this is mutable, so we cannot get the hash value, right? We'll get the error. Same as over here. Again, if you have the list and then inside the list, if you have any of the mutable object, so the hash will not work. So we'll not get the hash value over here, right? But if you have the tuple and the both object are the sequence data and both are immutable, so we'll get the hash value of that, right? Now in general, immutable types are hashable while immutable types are not. So while mutable types are not, right? So here it will be mutable types. Okay. So the number, string, tuples all are immutable. So you can find the hash of that, but list, set, dictionary, these are immutable, so you cannot find the hash of that, right? let's check the decimal value of the HASIB. We can get because decimals are immutables, right? Let's check the set. Set is mutables, so we cannot find the hash of that. But the frozen set are immutable, right? And for that you can get the hash value, right? Now, we'll talk about concatenation and the repetitions. Here we have this X as a list. In this list we have only one element, which is 2000, right? We can find the ID of that. Now if you do, so here is the ID of that, like here is the ID of 2000, which is this. Now if we do concatenate this X, like here we are concatenating this list, X plus X will get L. We can print the L, so we are getting 2000, 2000. So because we are concatenating this. But when you take the ID of these two objects, we can see that both ID are same. Right here, the both IDs are same. So even though, because both IDs are same, so those values, so both value pointing to the same location, same memory address. So is operator will also give you true over here, right? And because this entire this 2000 was immutable, but consider that if they are mutables like this inside the list, we have this object is mutables, but entire that like but inside that object this is immutables, right? So here we have this, so we have this list, we can check this again, we'll get the true over here, right? But what if we change the value, like because these values are immutable, so we are like this entire object is mutable, but we are changing the sequence data, so we are changing this 0 value to 100, right? If we'll take 0 value, we'll see this. If we'll take L, we'll see this. So what we are saying is, even though if you change one object, we can see that this change is happening for both object, right? Now, so this is what happens, right, when you do the concatenations, because they are pointing to the same locations. Now let's try this. So if even though if you do the repetitions, right, here we are doing the repetition, and inside that, because we know that with the repetition also, this all the objects are same, all the objects point to the same location, but when you change one value, we'll get the change in everywhere, right? Even though X has also changed, this was our X, we can see that X has also changed, right? To overcome this situation, you can use a copy method, right? Like over here we have this X. Now we are taking the loop of each value of this, so we are taking the loop of this, and then we are copying that loop, so and then we are copying that object. So when you copy the object, so it will create a new object over here, so it will not be the same object pointing to the same memory address, it will be the new address, right? We can see that when we see this again, if you change one object, that change is not everywhere. This is a sign that of the ID of all the different objects, the ID of this, ID of this, and the ID of this are different, right? X has also not changed over here, right? So if you are doing concatenation or repetitions, right, it is wise to use a copy method so that objects will be different, right? And yeah, this is it all about the basics of sequence type. Thank you very much.